Kistler Instrument, how can I support you?
Hi, this is Peter. I'm sorry to come up with such a basic question, but I am facing a new testing challenge. I'm measuring 0.5 millig to 50G vibration signals on an ultra lightweight structure. I checked your acceleration catalog and I'm highly overwhelmed by the choice of technologies offered to me. Can you please help me to select the right sensor technology and sensor type? Thank you.
Does this sound familiar to you? Well, first of all, there is no basic questions, and actually the width of acceleration choice on the market can be overwhelming to anyone. But let's look first at the sensing elements available out there. You'll find actually two major families. First of all, the ceramic sensor family. These are ceramic-based elements that are polarized by a big magnet, making it suitable then to be piezoelectric. And then the big advantage of it is that you can give it any shape you want and optimize it for shape and size for the sensor. The other advantage we actually have is that because you polarize it with a magnet, you make it highly sensitive, which means that actually you can measure very small signal without needing a very heavy or big sensor, or without having to amplify with the electronic inside the sensor itself. That means that the ceramic sensors are the lightest, smallest sensors on the market with the best noise performance. Having small and light sensor is always a good advantage in order to avoid mice loading effect, such as in this example here. That would lead to modifying the behavior of the structure under test, which is actually your case, Peter, here. You are on a lightweight structure. In addition, noise performance is key if you are actually looking for a wide dynamic range for your sensor. It means that you would like to measure 40G down to 0.4 millig with the very same sensor. Now, ceramic comes with a drawback. Actually, this material tends to have a polarity change when you subject it to temperature changes over the course of your tests. That means that it's preferable to use them in a stable environment. Is that your case, Peter?
I would say that 80% of the case it will be the case. So I could use ceramic sensors, but we'll be also performing the testing in a temperature chamber where we could run temperature cycles from 25 C up to 150 C.
Okay, well actually that case also happened during operational model analysis with vehicles. For example, if you do your test in the night at 10 degrees C or in the afternoon at 30 degrees C. In such a case, you need sensors based on a much more stable element, and these would be crystal-based sensors. The standard on the market is to use standard quartz. This already improves the sensor sensitivity response to temperature. As you can see on this curve, the response of the sensor with the quartz at 50 degrees C is only showing a 2% deviation compared to the calibration measurement done at room temperature. But on the ceramic sensor on the other end, you can already see a 10% deviation. Now, quartz being naturally piezoelectric, there is not much you can really do to make the element highly sensitive. What does it mean then? You need a compromise between having a lightweight sensor, but then you will need to amplify the signal with the inside electronic to make it the same sensitive output. Or you have a heavy sensor with heavy seismic mass, but then that make it much bigger and heavier than what you would get with ceramic sensor.
That is a pity, as I would basically need a triaxial sensor that can measure 50G, that can survive temperature changes, but that is not bigger than 5 grams. How can I do that? Is it then not possible?
Well, luckily for you, Peter, over the past 15 years, Kistler has been developing crystal-based sensors that are homegrown and called Piezostar. Such a crystal is showing even better temperature stability than standard quartz, but most importantly, it's 4 times more sensitive than a standard quartz. That allows then to have small sensors such as this one that are triaxial can measure 50G and weight 5 grams like you are looking for. Now, of course, these sensors will never equal, with the same size and the same mass, the noise level of the ceramic, but it's a great compromise if you have temperature issues. Well, basically, Peter, that's all you need to know. You have stable temperature, you go with ceramic sensor, and you go for the smallest and lightest sensor that can cover the signal level of your interest. You have unstable temperature, then you go for crystal-based sensor, preferably Piezostar ones. Then what's left is for you to choose if you want single or triax sensors, what G level you want, and how you want to mount your sensor. But most of our sensors in the portfolio have high flexibility of mounting thanks to all our accessories.
Perfect, thanks a lot. It is much more clear to me now. So I need to investigate a ceramic-based Triax 50G sensor for my standard laboratory testing and another Piezostar-based triaxial sensor for my testing in the thermal chamber. I'm not sure yet how I will be mounting them, so I need to think about it.
Exactly, Peter. Well, give me a call if at some point you want to discuss the option for mounting and their impact on your measurement results. Well, I hope this also helped you to understand better what options we have on the acceleration portfolio and the different technologies available with IEP sensor. And in another video, we'll be looking into the different mounting type and their influence on your measurement.